I'm starting with this question. This is question number 4 from the worksheet. Let me just copy this there. All right. The polynomial x raised to the power 4 plus 3x squared plus a, where a is a constant, is denoted by p of x. So you got this polynomial. P of x equals x raised to the power 4 plus 3x squared plus a. This is the polynomial. It is given that, अच्छा थोड़ा सा underspent है, gaps बहुत ज़्यादा हुए हैं letters के दरम्यान में, it's x square plus x plus 2. So we are given that x squared plus x plus 2 is a factor of p of x. What we need to do is we need to find the value of a and the other quadratic factor of this polynomial. So one factor is given, that's x squared plus x plus 2. We don't know the other factor, that's one thing. And we also do not know the value of a. We need to find the value of a here. What do we do? Any ideas? Can we use the remainder theorem to find the remainder and put that equal to 0? Will that work here? Why not?
So linear near factor.
Yeah. So remainder theorem only works when the divisor is linear. Otherwise, it doesn't work. This is not linear, so the remainder theorem is not going to work. What's the other option that we've got? We'll have to use long division. Okay. So let's use the long division process here to divide this polynomial by x squared plus x plus 2 and see what we get. You'll have to do long division anyway because you also need the other quadratic factors. You'll need the quotient from that long division process. So even if you could use the remainder theorem, you'll have to do long division in any case. Okay, that's going to be required in any case. All right. Now let's do this division. So you've got x squared, x raised to the power 4 plus, now be careful, the x cubed term is missing here. This term is missing, so that's 0x cubed. X raised to the power 4 plus 0x cubed plus 3x squared. And now the x term is also missing, so that's 0x plus a. This is what your polynomial is. All right. And now what we want to do is we want to divide it by x squared plus x plus 2. Okay, that's what you want to do. Divide करना है इसको x squared plus x plus 2 के साथ. Now, how does the long division process work? You start with the first term of the dividend and also of the divisor. So the first term of the dividend is x raised to the power 4, and the first term of the divisor is x squared. What do you have to multiply x squared by to get x raised to the power 4? You have to multiply it by x squared. And now you multiply x squared with this whole thing. What does that give you? That gives you x raised to the power 4 plus x cubed plus 2x squared. All right. Now you change the signs. This becomes minus, minus, minus. This gets cancelled. 0 minus x cubed, that is minus x cubed. 3x squared minus 2x squared, that is plus x squared. Then you have plus 0x plus a. What do you multiply x by to get minus x squared by to get minus x cubed? Now you'll have to multiply it by minus x. All right. Minus x into this whole thing. That gives you minus x cubed minus x squared minus 2x. Now change the signs again. This becomes plus, and this also becomes plus. This gets cancelled. X squared plus x squared, that is 2x squared. 0x plus 2x, that gives you 2x. Then you have plus a from here. Now, let's do the next step. What do you multiply x squared by to get 2x squared? You'll have to multiply it by 2. So you've got plus 2 here. 2 into this whole thing, that is going to give you 2x squared plus 2x plus 4. Again, you change the signs, minus, minus, minus. This gets cancelled. This also gets cancelled. And you're left with a minus 4. Now, can we go on with the long division process? We can't. We have to stop here because the degree of the remainder is less than the degree of the divisor. We can't go any further than this. We were given that x squared plus x plus 2 is a factor. Factor ka kya matlab hota hai? What's the first thing that comes to your mind when you read the word factor? That basically means that the remainder is equal to 0. Now you've done this long division process and you're getting a remainder at the end. This remainder should be equal to 0 for x squared plus x plus 2 to be a factor. So we put that remainder equal to 0. What does that give us? That gives us a minus 4 equals 0 and a equals 4. This is the value of a that we're getting. That's one thing that we have to do. Now, we were also asked to find the other quadratic factor of p of x. So one quadratic factor is x squared plus x plus 2. What about the other factor? This quotient is also a factor. So we'll write down here explicitly because you've been asked about this. You're not just going to leave it like this and assume that the examiner knows that you know that this is the other factor. You have to write it down explicitly. You'll say this is this other quadratic factor is x squared minus x plus 2. This is the other quadratic factor. This is what we were looking for. Makes sense? So if we had to factorize this, we'll factorize this polynomial, p of x, we would write it as, the factorized form of that polynomial would be x squared plus x plus 2 into x squared minus x plus 2. This is the factorized form of that polynomial. Okay, let's try this. This is question number 18 from the worksheet. Let's attempt this one. All right. So we have this polynomial ax cubed plus bx squared plus x plus 3, where a and b are constants. It's denoted by p of x. It's given that 3x plus 1 is a factor of p of x, and that when p of x is divided by x minus 2, the remainder is 21. We need to find the values of a and b. Now, remember what factor means? Factor means that the remainder is equal to 0. So we've got this polynomial, which they are denoting by p of x. P of x equals ax cubed plus bx squared plus x plus 3. This is the polynomial. We're given that 3x plus 1 is a factor. What that means is, when we divide by 3x plus 1, the remainder turns out to be equal to 0. That's one piece of information that we're given. And then we're also given that when p of x is divided by x minus 2, in that case, the remainder is 21. So when it's divided by x minus 2, the remainder turns out to be 21. All right. Now, using this information, we need to find the values of a and b. Now, what we can do is we can use the remainder theorem, right? We can, because this is a linear factor and this is also a linear factor. They're both linear factors, so we can use the remainder theorem in both of them, right? So how do we use that? 3x plus 1, you put this equal to 0. 3x plus 1 equal to 0. That gives you x equals minus 1 over 3. And you put this value of x in that polynomial. You find p of minus 1 over 3. You evaluate this thing. In place of x in this polynomial, you put minus 1 over 3 and see what you get. A into minus 1 over 3 whole cube plus b into minus 1 over 3 whole squared plus minus 1 over 3 plus 3. Now, what does this simplify to? Remember, when we take cube of negative numbers, the negative sign stays there. Minus 1 over 3 whole cube, that's going to give us minus 1 over 27 times a. Minus 1 over 3 whole square, that's 1 over 9. So that's 1 over 9 times a. I'm sorry, b. Minus 1 over 3 plus 3. Now, this is the remainder, right? So we're inputting minus 1 over 3. That is going to give us the remainder. But they've also told us that the remainder is 0. So what we do is we put this equal to 0 because the remainder has to be 0, right? So we put this whole expression equal to 0. Now we simplify this. What we can do is we can, okay, let's actually add these two first. They're going to give us minus 1 over 27a plus 1 over 9b. 3 minus 1 over 3, that is 8 over 3. And now you can multiply the whole equation by 27 to get rid of the fractions. That's give us minus a plus 3b plus 8 times 9. What's that? That is 72, I think. And from this, we get one equation, which is a minus 3b equals 72. Okay. Now, this is one equation, and we have two unknowns. We can't really find the values of a and b directly from this equation. We'll need some more information. Let's look at the other divisor that we're given. We're also told that when this polynomial is divided by x minus 2, the remainder turns out to be 21. So now from this, what you can do is, using this, what you can do is, you can just input in place of x 2, because x minus 2 equals 0 gives you x equals 2. And now in that polynomial, you input 2 instead of x. So you find p of 2. Let's see what that gives us. A into 2 cubed plus b into 2 squared plus 2 plus 3. And now in this case, we're given that the remainder is 21. We are getting this remainder. So we put this whole thing equal to 21. 21 equals 8a plus 4b plus 5. And that gives us 8a plus 4b equals 21 minus 5, which is 16. We can simplify this, and that gives us 4a plus b equals 4. No, sorry. Something wrong here. Yeah, should have 2 here. 2a plus b equals 4. This is another equation that we've got. Okay, you've got two equations, two unknowns. You can solve them simultaneously and find the values of a and b from that. Okay, let's find these values. We can use any method that we are comfortable with. Let's say, let's make a the subject here. A equals 72 plus 3b. Now you can take this thing there and put in the other equation. Input kar de. What does that give us? That gives us 2 into 72 plus 3b plus b equals 4. Now simplify this. You get 144 plus 6b plus b equals 4. 7b equals minus 140 and b equals minus 20 from this. Put this back in the other equation now, and that's going to give us the corresponding value for a A equals 72 minus 3 into minus 20, and A turns out to be equal to 72 plus 60, which is 132 in this case.
Sir, A 72
Does
plus
that make sense?
3B.
Oh, sorry, yeah, it's plus 3B. Thank you for that. This is plus 3B. So that becomes 72 minus 60. That's actually 12, not 132. This is just 12. The value of A turns out to be 12. This is what we had to find. We had to find the values of A and B. A is equal to 12 and B is equal to minus 20. ये दो values हमें figure out करने थे. Question number 3. Let's try this. There's this polynomial x cubed minus 2x plus a is denoted by p of x. P of x equals x cubed minus 2x plus a. It's given that x plus 2 is a factor. X plus 2 is a factor of p of x. We need to find the value of a using this. Now, since x plus 2 is a factor, we can use the remainder theorem, right? It's a linear factor. We can just put this equal to 0, x plus 2 equal to 0. That gives us x equals minus 2. So if you were to input x equals minus 2 here, the remainder should be equal to 0 because it's a factor. Factor ka matlab hota hai that the remainder is equal to 0. So that's what we do. We put x equals minus 2 here. P of minus 2, that equals minus 2 whole cube minus 2 into minus 2 plus a. Now, since the remainder should be 0, we put this equal to 0. That gives us minus 8 plus 4 plus a, and a turns out to be equal to 4 from this. Okay, that was pretty straightforward. A equals 4, the first part. Now the second part says, when a has this value, that means when a is equal to 4, find the quadratic factor of p of x. Okay, so now the polynomial is this, which is x cubed minus 2x plus 4. This is the polynomial. We know that x plus 2 is a factor already. What is the quadratic factor? How do you find that? We know that x plus 2 is a factor. When we divide this polynomial by x plus 2, we would get a quotient. That quotient would be the other factor of this polynomial. And that's going to turn out to be quadratic because this is cubic, this is linear. So the remaining factor is going to be quadratic. Let's do that division. So we have x cubed. The x squared term is missing, so we have 0x squared in place of that. Minus 2x plus 4. We divide it by x plus 2. Now, what do you have to multiply x by to get x cubed? You multiply this by x squared. X squared into this whole thing, that gives us x squared plus 2x. Now change the signs. This becomes minus. Sorry, there's something wrong here. This should have been x cubed, and this should have been x squared. This is x cubed plus 2x squared. Now, when we change the signs, this gets cancelled, and 0 minus 2, that gives us minus 2x squared minus 2x plus 4. Again, you think, what do you have to multiply x by to get minus 2x squared? You multiply it by minus 2x into this whole thing now. That gives you minus 2x squared minus 4x. Change the signs again. This gets cancelled. Minus 2x plus 4x, that is 2x plus 4. Now, x multiplied by 2 gives you 2x. So you multiply by 2 here. 2 into this whole thing, 2 into x plus 2. That is going to give you 2x plus 4. Change the signs again. Everything gets cancelled. And you have 0 at the end. The remainder is 0. That confirms that your process is correct because x plus 2 was a factor. So remainder should have been 0. What's the quadratic factor now? It's x squared minus 2x plus 2 That is the quadratic factor that we were looking for. यहाँ पे हम लिख देंगे. Let's say the quadratic factor is x squared minus 2x plus 2. This is the quadratic factor. All right. Any problems with this? Make sense? Okay.
Sir,
So
sir, one question.
yeah.
How do we know we should not factorize the quadratic factor?
Yeah, so that's a good question. How do we know if we should factorize this quadratic factor or not? Well, you always try and do that. If it can be factorized, you should factorize it. So can we break the middle term here? Is that possible? Can we do that? Does anything work? It doesn't, right? We can't
No.
factorize it. So normally whenever you can break the middle term, you do that. In this case, though, they had asked you for the quadratic factor, right? So you know that you have to leave it as quadratic, right? So you don't even have to think about it. But when they say when they ask you to factorize something, and especially they use the word completely, factorize something completely. So I might show you, let me actually show you some question from here where they ask you to factorize something and they also use the word completely. So when they say something like this, factorize p of x completely. This word completely is mostly a hint that if you're getting a quadratic factor, you can further factorize it and make it linear factors. Okay, so that they generally give you a hint using this word completely. But even if they do not give you any hint, you should always check if you can factorize the quadratic factor further. If you can, you should do that. If not, you can just leave it like that. Okay.